finally ready to start. Wonderful. This is yeah. All right, let's try this out. All right. So this is how to be more efficient with Bash. So I don't know if you guys can see the right-hand side of the screen over here, but I have let me try moving it over slightly. I have some notes on what we're going to get to. The stuff down here, I don't know if we're actually going to reach if we have time, especially since I just burned 11 minutes doing nothing, but hopefully we'll get there. All right, let's get started. So first we're going to start about the overview of what the command line is. So originally, all the computers were... Oh, I have to move it over. God damn it. Alright, let's move it over more. How's that? Let's see, OBS. Yeah, alright, that looks a little better. There's still some new lines that we could fix, like over here. But, yeah. But let's go here, move this over, whoop, whoop. Okie dokie. Coolio. So let's first start off with a history of Bash. So originally, all the computers were command line. Although technically, that's not true. Like punch cards weren't technically command line, but those are ancient. But at one point in time, all mass-produced computers were command line. Then Mac came out, and it was the first mass-marketed operating system with a graphical interface. Windows copied them, which is why they actually have the name Windows, because they have Windows interfaces. Oh my god. If I move over left, I'm not going to have anywhere to type. Oh wait, I know, I can just make it smaller. How's that? Smaller, better? Yep. Wonderful. Perfect. Alright. So, back to... let me just start over. Alright, so let's talk about the overview of what the command line is. So, originally, all computers were command line only, barring the punch cards. The Mac was the first mass-marketed operating system with a graphical interface. Graphical interfaces have become the dominant way for the average person to interact with computers, as they're intuitive. Having to remember all the random commands is not a very good way to learn how to use a computer when you're first starting out. Some people, though, are still stuck in the Neolithic ages and use command line editors like Vim or Nano, but to each their own. Originally, each operating system had their own shell. The most popular of these is the classic SH, written by Ken Johnson in 1971. I stole that from Wikipedia. The SH shell is the gold standard these days, even though it's a bit antiquated. All POSIX compliant systems, if you know what those are, i.e. all non-Windows computers these days, Mac, Linux are the only ones really, they will have at a bare minimum SH installed. Bash or SH spawned off a lot of shells with varying degrees of compatibility, such as Bash, ZSH, KSH, TCSH, CSH, Dash, tons of them. But of those, Bash is the most successful, and it has beat out nearly all of its cousins. And all non-barebone systems will have Bash installed, and thus you should learn it, because everything has it. One thing is, though, is that Bash is slowly being phased out after, like 30, 40 years of life. Within the last 2 years, Mac replaced Bash as the default shell as ZSH, but 90% of what you learn here will be applicable to ZSH too, and I'll point out the differences if they arise. I personally use ZSH. It's a little better, but it's not much better. Yeah, so... Oh, fish. Yes, how did I forget fish? So that is the overview of Bash. We've finished this out. Now we're going to go over a crash course on basic Bash, just in case you guys don't know. And this is where we're also going to be typing on the command line. So, this will just be a brief overview. When typing on the command line, the first thing you do is type in the command, and everything after is an argument. Echo, hello, world. So, hello is an argument, world is an argument, and echo is the function, or command, or whatever you want to call it. There's lots of special characters in the shell, and you have to avoid those by using quotes. So, echo hello world, for example, to avoid the square brackets being interpreted specially, or echo to avoid $ being interpreted specially. The single quotes are more permissive. They have some special things you can do with them, like $ are special within double quotes. But single quotes are the most restrictive. Every single thing in them is taken literally. So if you want to print out multiples, or if you want to print out single quotes within single quotes, you have to do something like this. Whoops. Why wouldn't... You have to stop the single quote, escape a single quote, and start a single quote again. And it's not all that terrific. But yeah, it's not great, but it's what we have. There's also backslashing, which you see here, but that's just to escape any single character. So the command right here is one of a few things. It's either executable, like /bin/pwd or something like that. So that's an executable. It's a shell built in, like FG or break, FG or break or stuff like that. Those are shell built-ins. There's aliases, which we will get to at some point, and also user-defined functions, which we'll also get to. So, for example, let's see, where are we? Cat lorem. This right here is a cat is a function. You can use which to see where it is. So that's the path to cat. Some things like ZSH, or if we do which echo, that's the path to the echo. However, if we do ZSH, it's a built-in. So that's one of the differences between them. The only real reason why that's important is because ZSH is slightly more efficient, but not that much. All right, so it looks fine. The bitrate seems fine. Okay. So the interesting thing to note is that when you're typing in these commands, Bash has to figure out which one it uses. There's a lot of rules behind which ones it uses, but the main important thing is the executables. How does it find an executable? So if you type in the literal path of something /bin/echo hi there, it'll use that if you type in the path. But if you just type echo, how does it know where to go? So what it does is it looks through this special variable called $path. And if you look, it has these different colon separated segments, and it'll go through and look through each segment one at a time, and once it finds one that has the function in it, it'll run it. So what you can do is if you want to write your own functions that you can use, you can actually add in something to this path, and then you can do stuff. So like, we'll do that later, but you can add in, I usually add in ~bin to mine, because I have some files that I write in there, like I have one called subl, which will just open up a thing in Sublime Text. Lastly, there's this thing called ps1, which is how I have my prompt here. That's just you can use that to customize your prompt. I like in my ZSH prompt, I have it so it has like the current time, what command number it is, what folder I'm in, stuff like that. So you can do stuff like that to make it a little easier to look at, but the basic one's fine as well. All right, that is our crash course in basic Bash. Oh, I forgot to mention variables. Variables are really simple. You say variable name that's foo equals then value, and if you want to access it, you have to use a $sign beforehand. That's about it. There's array variables and associative arrays and stuff like that. But those, we're not going to talk about those right now. They're not really all that important. All right. So now that we're done with that, we're going to go on to the common commands. So we're going to start off. Ooh, whoops. We're going to start off with one of my favorites, yes. If you've never seen this before, it's hilarious. You type in yes, and it just Y. It just prints Y forever and ever. This is also a good point to mention that if you hit Control-C, it'll stop a program. So Control-C stops our program. You can also give yes a command. You can say yes foobar, and it'll just print foobar forever. Now, this might not seem useful, but there's two places I found it really helpful for. If you want to make a massive file for some reason to like test how well your code can handle big files, you can say yes, and we're going to output it to temp.txt. And we wait 1, 2, 3 seconds, and then you can get the word count of it, which will be the next thing we do. And it has 885 million bytes in it. So yeah, massive file. The other thing is on some Linux distributions like Yum, for example, when they're asking you if you want to install something and they say yes or no, you can say yes and type it in there, and it'll just confirm everything for you. It's less useful, but it's still there. Yes is probably one of the simplest command line things there are. But anyways, that will segue us into our next topic. Does my prompt ever look up when too much text is in the history? Not really. I generally try clearing my history fairly often, or Command K to clear my screen, like this, because I just don't like having extra commands in the background. However, I do have this history, which I can go back and get my old commands from. So I use that as kind of like the backup. And if a variable's in a list and it expands unquoted, yeah, that's right. That's true. All right. So now that we have that, we are going to go to word count. So word count is one of these fun things that word count's one of these fun things that's really helpful when you start learning about it. So I have these different files: cat lorem1, cat lorem2.txt, just lorem ipsum. I just copied this offline. So what you do is, if you want to see how many words... Oh, my computer's going to restart. No. If you want to see how many words there are in lorem, you can say word count lorem1.txt. And so what you do is you say word count, how many words there are. There are 93 words. There are 5 lines and 661 characters. It doesn't look like it, but there's only 5 new lines. There's like a new line here, new line here, yeah. So what you can do here is you can actually see how many words there are. So what we can do is, like, we can use yes and pipe it into word count. Oop, nope, never mind, ignore that. So we can use word count to figure out how many words there are. This is also helpful for when you want to see how many words there are in multiple files. You can do word count lorem1.txt, lorem2.txt, etc. And it'll tell you how many words you have and how many bytes. This is great when you want to see, like, the size of some binary. You have some C file you made, so like word count. So my Squire programming language has 139,000 bytes in it. The line and the other stuff isn't relevant. So what you can do is you can say, I want only how many characters there are in there, only how many words there are in there, only how many lines there are. Yeah, so that's a nifty little thing. Oh, someone can't see. Is that my fault, or? I don't know. So that's word count. You can't see. Oh, you can't see the bottom. Whoops. Okay. So let's see. Where can you see? Let me pull up OBS. Where does this thing end? All right. Can you see that? There you go. Okay. Okay. Sorry. So you can do word count this to get the word count of individual things. You can do word count minus C to get the amount of characters, amount of words, and the amount of lines. So that's that. Yeah, sorry about that. I am not used to having a tiny screen. I'm doing this on my monitor. Yep. All right. So after that, we'll go into top. So top is probably one of my favorite commands. If your computer ever heats up really badly, you can use top to look. So top minus order by CPU. And what this does is it's like, okay, so I have Discord is... What? Why is Discord being dumb? So OBS is taking up 57% of my CPU. So kernel task, I don't know what this is. This is just my computer doing something. But this right here is it being really process intensive. So what you can do is you can actually copy this PID and you can use it to kill something. So for example, if we type in yes, and yes will just go forever, eating up a lot of CPU. You can go over to top, and if you look, yes is going to rise up. And right there, yes is taking up a lot of CPU, 472. And so what we're going to do is we're going to take it, we're going to kill it. So, whoa, right there, 19210. So we're going to go kill 19210, and it stopped. So that way, if you ever run a program and you for some reason can't control C it or something, maybe you ran the program and accidentally closed the window or something like that, or you ran it in an editor and the editor doesn't have a way to close it, you can use top minus O CPU to list things. You can find the process ID to kill it. Last thing for the common commands that we're going to look at is this CD. Everyone knows CD. If you use CD without an argument, it brings you to your home directory. But the really helpful thing, that small little thing, you can do cd minus and it brings you to your previous directory. So like cd ipsum, and then I can go, oh, I want to go back. I didn't mean to go there. You can go back with cd minus. Yeah, cool. All right, so, last fun little thing. We have a user shared dict words. So this right here is a file that most computers have that is just full of random words. There's, I think, 249, wow, there's 235,000 words in it. Editors can use it for spell checking or auto completion, stuff like that. But we'll use it later on for some of our piping commands, and we'll use this. Environment variables and how to set them up. Yeah. So, are you talking about the bash RC? We have that down here. If we have time, we'll talk about those. Whoops. Not sure if we will. I wanted to go into these things, the bash expansion and piping utilities first, just cover them. But if we have time, we can. I think I'm gonna, because it's a little late, I'm probably gonna go to another hour from here. So, yeah. All right. So, on to the meat of this presentation. We're going to talk about bash shell specifically. So we're going to go and we're going to talk about expansions. So first off, if you look at this, we have a bunch of lorem things. So what we can do is, if we want to just list all the lorem files, you could say go lorem1.txt, lorem2.txt, lorem3.txt, lorem10.txt. But that's a pain in the ass. So what you can do is you can say echo lorem star.txt. And what star will do is it means just expand to any amount of characters as long as there's a file name that matches that. So that'll directly do it for us. It does it in a specific order. That's not what I did, but it matches the files we have. What you can also do is, if instead of asterisk you use question mark, asterisk is a single character, while question mark is wait around. Asterisk is as many characters as you can. Question mark is a single character. So if you notice, it's omitting lorem 10 because 10 has an extra 0 there, while these don't. You can also use square brackets. That'll only be those characters. So I don't want lorem 2. I just want lorem 1 and 3. You can have those. There's also a asterisk, which you can use for like subdirectories and stuff, but that's not really all that important right now. It's a little too. It has some weird edge cases I don't want to talk about. But now for my favorite part is brace expansion. This is really cool. So if you want to say 1, 2, 3, 4, 5, you can do 1, 2, 3, 4, 5. If you know what sequence is, you can also do this. But what braces do is you can do this, 1 to 5. Why this is really helpful is because you can add things to the beginning and the end of it. So you could say copy. You could say echo abc.txt, and you can use that. So I can do echo lorem 1 to 3.txt, and it'll echo out all these lorems. It is? Better now? Yep. Cool. Wonderful. All right. So we have the curly braces, which can expand to things here, but you can also put commas in them. So echo lorem 1, 2, 3.txt, stuff like that. Now, one of the places this is really helpful for is copying things. So let's say you want to make a backup of this file. Like, let's say I have lorem 10, and I want to make a backup of lorem 10 up here. So you can say copy lorem10.txt, lorem10 backup.txt. That's not too bad. Let's remove it. It's not too bad, but let's say you have to type in the whole path. Whoa. Copy /user /samp /temp /lorem10.txt /user /samp /temp /lorem10 back.txt. That's a pain to do, especially like if you have to type in the absolute directory because it's somewhere else that you're not using. That's too hard. So what we can do is we can do this: lorem10 backup.txt, copy lorem10. Whoops. So what this does is it'll expand out this to two things. Let's echo it so we can see what it's doing. What it'll do is it'll actually expand it out. So the first thing will have nothing because there's nothing before the comma. So it'll just be lorem10. And the second thing will have dash back afterwards. It'll be lorem10 dash back. So with this, you can use this to make backups, or you can also move files. Like let's say you want to change it from a text to a markdown file. You can do lorem10 back.txt. Let's make it a markdown file instead. Now it's a markdown file, lorem10 back.md, because we use this brace expansion. It's super helpful. I use it all the time. All right, next up is this fun thing. Bash actually a spell check. So what you can do is, let's say you say, whoops, I spelled echo wrong. So what you do is you do caret, what you spelled wrong, and then what you want to replace it with. And it'll go through and it'll fix it for you. So what it'll do is it'll rerun the previous command, but fixing that thing. So, but it'll only do once. So if you say, if you do something like this, and then you fix it with, it'll still say the other two ones right here. It'll still say echo or echo twice in a row. And it also doesn't appear in history, which is great because you don't want history, you don't want the caret thing to appear in history, you want the replacement to appear. This is just a small little thing that is really helpful, especially like I'll sometimes do, and like, uh-oh, I spelled that, and I have to go all the way back to the beginning, like caret all the way over. Or you could do, I'm not in Git repo, but yeah. Another useful thing here is actually, what was I going to say? I totally forgot. Damn it. Oh, yeah, right. So for me, at least, I don't know if any of the other people have it, but at least on a Mac terminal, if you hit Control-A and Control-E, it'll go to the beginning and end of the line. So Control-A, you can go here. Control-E, you can go here. That's really helpful. I think that's a standard on most things. I'm not positive. Like, if I open up Spotlight, I can hit Control-A and Control-E to go to the beginning and the end of it as well. So that's just a helpful little thing. Instead of Command left arrow and Command to right arrow, which don't work in the command line. So that might be really helpful for you Mac users. Alright, we're going to go to history expansion next. This stuff's pretty cool. So I showed you guys earlier, but we have this history command. And what this does is it shows you all the commands I've ever run that have been saved in my history. All these commands. And what you do is, like, let's say you want to go Control-A. Oh, yeah, on Windows, Control-A is select all. I'm on a Mac, so that might explain it. Yeah. So, where was I? History expansion, yes. So, let's say I want to go up here and I want to do this echo command, command 265. Well, I have a few options. One, I can do echo lorem123.txt. I could type it. That's a pain. Especially if it's a longer command, you don't want to do that. You can up arrow a bunch to try to find it, but that's also terrible. Or you can use history expansion. So what you can do is you do exclamation point. This is another special character. And then you do the number. So we're going to execute command 265. So exclamation point 265. And it will run that. And it tells us what it's going to do, and then it does it. So you can use this to execute all your commands. And actually, if you look at my ZSH, I have the command number built into my prompt. So that way, I can go back and I can say, oh, I want to run command 1 because I know it is. Oops, exclamation point 1. Boom, it runs it. I really like this expansion, but I don't use it all the time because there's something else that's even better. There's also, if you want, let's go back to this echo thing. Let's say I want to go and I want to run this cat command right here. Let's say I want to run this cat command. So I could go back and write 252, but let's say I don't remember exactly what number it is, and I don't want to go search through this entire thing, but I remember it was cat. It was the most recent cat command I did. what you can do exclamation point cat. And what we'll do is it'll go back in history and it'll find the very first, or the most recent cat command you've done. So most recent cat command I did was cat user shared dict words word count. So if you look way up, where'd it go? Right here, 253. I catted this thing, and that was the most recent cat I did. So if you start with exclamation point cat, it'll go do that. It'll be the first command with cat in it. You can also do short things. So if you do C, it'll go back and cat starts with C, so it'll run that. But it won't do. You can't, if you have two cat commands or two echo commands, you can't run the second to most recent. You can only run the most recent one. That's a little bit of a pain, but it's okay. Yeah, Control E is amazing. It's so helpful. Also, what we can do here is we can also do something like this. Like, let's say you type in something like foo bar baz quux, and you're like, oh, I meant to CD to that, or I meant to echo that, or something like that. Well, you can hit up arrow command A and go to the front, or you can use exclamation point. So like exclamation point's the history command, so you can either use it for numbers, for the command number, or words for the last command like that. But exclamation point is the previous command. So echo, these two will just echo what we did before, the previous command. So we can do that again, and we echo twice in a row, because that was our previous command. So this is really helpful for things like if you're copying some file or some command and you forgot to write sudo or something, you could do sudo exclamation point, and it'll run the command beforehand, which is really nice. There's another useful thing here, more useful things from the history. Let's say we wrote that, and we want to get actually first let's do this. So let's say we make a new directory called foo bar baz quux, and we want to cd into that. So normally what you'd do is you'd say cd foo bar baz quux. Okay, not too bad, but you have to type the entire thing, and it's like I said before, if it's a massive path or something, you really don't want to do that, and sometimes it might be hard to copy it or whatnot. So what we can do, we can use the cd minus again, rm minus r foo bar baz quux. Nope, what am I doing? So we're going to make this again, and what we can use the exclamation point $, which is the last argument of the last command. So I actually hit Control C on this one. You can't see. Let me do this again. We're going to do cd exclamation point $. So what that does is that means the last argument, last command, and we'll change to it. So we can just make a directory and then immediately change to it in like 5 characters instead of a bajillion like you normally have to do. An easy way to remember that is that it is the last, if you know regex at all, the $ is the end of line in regex. And as you'd expect, there's also an exclamation point caret, which is the beginning of the line. So you can see echo foo bar baz quux, and I do echo exclamation point caret, and that'll just give us foo because it's the beginning of the line. I don't use the exclamation point caret as much as the exclamation point $. The $ I use a lot. You like copy foo bar. I don't know if it's recorded. You'd have to ask Eisenjan or something. I don't know how. But I will be putting up all these things over here. My notes. I'll be uploading this thing if you want. I could probably flesh it out a little more too. Yeah. Well, after this, I'll probably flesh out the notes a little more, make it a little more helpful. Like I'll say what exactly each of these things do and stuff like that. Okay, so we have exclamation point $, exclamation point quote, or caret. So what we can do is, just like you can do exclamation point numbers to be that command, you can actually specifically select the argument of a command. So let's say, oops, wrong place, echo foo bar baz, and then we could do echo exclamation point :2. So what that says is we're going to go to the previous command, and we're going to get the second argument. So that's bar. What we can also do is we can do echo so it's, oh boy, okay. So what we do here is exclamation point -3 says we're going to go back 3 commands. So one command. Or so this could be this is our one command. We're going to go 2 commands. We're going to go 1 command, 2 commands, 3 commands. We're going to go back 3 commands, and then we're going to get the first argument of that foo. So you can use this to go all the way back and get any number of commands you want. You can get any argument you want from them. I don't really use this a whole lot because I find exclamation point $, i.e., this is also equivalent to this. I find this just to be the most helpful because I use it a lot. But you can use the other ones as well. I just wanted to point out that these existed. Or this right here exists. I probably should fix my spelling. Yeah. I was going to get into job control, but that seems like a little extra for now. There's just one thing I will show you. If you ever run a program and sometimes Control-C doesn't work and Control-D doesn't work and none of that stuff works, you can actually do Control-Z. And what that does is it'll stop it immediately. And just like Signal 9 cannot be interrupted, Control-Z also cannot be interrupted. And what it does is it just sends a stop signal. It says stop, and you can later on do foreground $1 or kill $1. And foreground will start it again, and kill will stop it entirely. And then it's gone forever. I can get into more of the job control later if you guys want, but it's not all that important. I just want to show that one thing. All right, yeah. All right, I'm gonna take a quick break and read that. I need to write a bash script on terminal. I need to write stuff. Exit Control-C. So cat is reading from the command line. If you type nothing, it'll just read from standard in and read for you. You can use the read function to read stuff in, and it'll put it in the reply variable. You can do that if you want to read stuff. So you can do read, and then you can do something like that, and you can do reply into in or something like that. I don't know. Don't really know the question. Oyoko or Oyoka. I don't know how to pronounce that. Yeah. Any questions so far on the stuff before we get into piping? It's gonna be fun. Whoa. Let me go check the Discord too, see if there's... Whoop. You want stuff to stay in the infile, so what do you want to do? You want to just read it? So if you want to write to the file, you can say echo hi. Whoa. Nope, no, not today, Discord. Go away. Oh, lovely. You can do that to read something or write something in. You can do and this is how you'd read from a file. Yeah. All right. So if we have no other questions about the basic bash fun stuff, I guess we'll go into piping. So one of the really important things about bash, and the thing that makes it so incredible, is that it has this piping feature. I've already used it a few times. This pipe character here. So one above the return key, below the delete key, the backslash one. It is used to take input from one command and put it into the output of another command. So many utilities, like we can use word count. You can say word count, and it by default does nothing, because you can either give it an argument on the command line, or you can pipe something into it. So what we're going to do is we're going to cat this, and we just cat it all out to stand out, or we can pipe it into word count, which puts it into word count standard in. And almost every command you'll find that is a bash command has two options. Either if you give it file names, it'll run on those file names. But if you don't, it'll just read from standard in, which allows you to pipe things like this in. So you can cat it to get all the words in it. And we can find the word counts of that. This, as opposed to saying word count that. Same thing. You should generally prefer this, but we're going to go... you should generally prefer just directly pasting in the path when you can, if it's something simple like this, instead of just catting. But when you want to do something more complex, you definitely should use piping. So we're going to start off with the simplest piping things, head and tail. So, head of something just gives you the first 10 lines, and tail of something gives you the last 10 lines. You can also say head minus n20. Whoa, no. Head minus n20 to give you the first 20 lines. If I remember correctly, minus C will give you the first 40 characters, stuff like that. So you can use these to get, like, if you want to get the first, or the you want to skip the first 10 lines and you want to get the next 10, you can do cat, cat this, then head, minus C10. So that'll get you the, not C, N. So what this will do is it'll take the words and look at the first 20 lines and then look at the last 5 lines. So look at the lines, I think my math's right, 15 to 20, 15, 21, maybe there's an off by one error there. But you could use this to get certain segments of things. So one thing I've used this for is like when I have a massive file and I want to use it to pipe it into certain processes that just aren't able to handle that. What I'll do is I'll be like, oh, this file has 10,000 lines. I'll do head minus n 1,000 or 2,000 or something, and then I'll just gradually go one by one, bit by bit, and kind of combining head and tail to do that. So I'll do tail, or head minus n. I'll do head minus n 2,000. I'll do that, something like that, and then I'll do that to get a massive file in. Yeah, XR. Oh, I forgot about X. I should have added that in here. Maybe later. All right, so that's head and tail. There's also more and less. We'll look at those now. So what more is effectively a older, worse version of less, and what less does is it just gives you doesn't output everything. So if you notice, the few times I've cat the entire words out, just fills the entire screen. Really unhelpful. If you want to just get a small subsect, you can do pipe it to less. What this does is it'll give you screenfuls at a time. You can hit space to jump through them, or you hit shift space to go back. No, that's not on Bash. That's somewhere else. You can hit space to go all the way through. You can also use slash to look for something. Slash ZZ will bring me down to the first instance of ZZ. Stuff like that. Nope. I want to go slash starts with the QU. Woo! We find all the things that start with QU. So less is an extremely helpful command when you have large outputs. Generally, when you have outputs of this size, I just open them up in Sublime Text and look through there because I'm more used to that and it's better. But whenever I like SSH into servers and stuff and have to look at large files, I'll use this to look at log files or stuff. So I'll say less log file name and I'll do slash and I'll look for a specific thing in the log file. Like, oh, if I'm trying to see like failure, I'll do slash failure and I'll go look for the first failure instance and I'll read through that and stuff like that. So that's less for you. Next up, let's move less up here. Next up, we're gonna go to cat, t, and this other special syntax. So, we've already seen cat all the time. Cat's everywhere. What cat is used to concatenate stuff. So normally, what you do is you concatenate it from input to standard out. So you cat lorem1.text. You can concatenate that from standard in to standard out, but you can also concatenate it to the standard out of another file, another function. Like what we've seen before, you can do pipe it into word count. However, what we can do is this is such a common pattern, doing something like this, that Bash actually provides us a special syntax for it. And it's slightly different. You can do word count, this. So what this special syntax says, it's less than, parenthesis, something greater than, is it takes that input, it takes that thing, converts it into a file, and passes it as that argument. So, for example, if you want to say cat echo hi, echo bye, here, let's do this first. So what this does is it takes each of these things and it converts them into files that when you read them will give you the contents hi and give you the contents bye. So this is like you're piping in, but you can pipe in more than one thing at a time. So we're going to say echo hi and echo bye is going to give us these two different files. These are the different files. If we read from those files, it would give us those contents. So let's try that. If we read from those files, it will give us hi and bye because the contents of these files are that. So you can use these less than parentheses stuff greater than to kind of make anonymous files, kind of like lambda files, if you will. You can also combine this with T, which if it's kind of like the letter T, where you have input coming in and then it goes out two directions. So you say cat. Hold on, let me copy this. Cat that thing, and then we're gonna go. We're gonna get the first 50 lines, and we're gonna T it to foo.text, and then we're gonna just, I don't know, count how many words there are. So what this does is it says we're gonna cat this out. We're gonna get all the words here, but actually, or all the lines, but we're actually gonna get the first 50 lines, and then we're gonna tee it out. So what we do is we take the input and we're gonna first write it to foo.text, but we're also gonna continue passing it forward. So if you look at foo.text, it also has the output of that. So what you can do with this is really helpful for debugging your piping. So when you're in the middle of a pipe or something, you want to figure out what you're doing wrong, you can tee it out to a file and you can go read that file to see exactly what the pipe was at that point. You can use this also to do stuff like if you want to save intermediate results or something, stuff like that. I only really use this when debugging, but it's helpful otherwise as well. Yeah, so that's head T. That's T cat, and the special, I don't even know what this is called, but I use this a lot. I kind of call it a bird because it kind of looks like a bird here. There's the beak, the head, the eyes, I don't know, something like that. Alright, we're going to go to grep and set. Actually, no, let's go to sort unique next. So one of the things that Bash lets you do is it lets you sort things and sort things correctly. So let's say we have let's make a new file. So we're gonna say make a new file called is it not working? What the hell just happened? Did Sublime Text just crash me? People hear me? Oh boy, okay. Whoop. Alright, sorry about that. My computer decided to be silly for a second. Alright, cool. Wonderful. So we're going to open this in Sublime Text 4. We're going to make a new file called sortme.txt. Well, that sucks. You can't hear me. We're gonna say foo, or let's just say 1 2 3 1 5 1 5 6 9 2, something like that. Let's say this is our file. We probably have something more descriptive elsewhere, but let's say this is our file, and we want to just sort it. So what you can do is you can say, wait, no, it's not foo.text. Foo.text. What'd I name it? Sort me? Yeah. So what this will do is it'll sort it in, I think it's lexicographical order. Don't quote me on that though. And they'll sort it all for you. And with this, you can say, okay, how many different things? That's about it. That's all it does. It sorts them. The important thing here though is that if you try making it unique, like that way we can get a unique thing. But if you say unique sort me.text, it doesn't actually make it unique. And the reason is because unique will only compare adjacent lines. For some reason, I have no idea why. Maybe it's efficiency or I don't know. But unique, if you ever use it, will compare adjacent lines. So what you have to do is you have to sort it first and then get unique, which is dumb, but that's what you have to do. So this is a way to get unique lines and try to make something worthwhile. So one of the things you can do is like, oh, if you have when I was debugging one of my pieces of code, I'd have every single spot in the code. I'd do like something like this. It'd be like if foo printf here 1, else printf here 2, whoa, here 2, and then we do like printf here 3. And what you do is if you run this and your program is outputting millions of lines of code, it's going to be a pain in the ass to go through and find these, or even see how many there are. So what you can do is you can say, okay, I want to see exactly which places it went to. So you can say, okay, I'm going to take it and I'm going to sort the output. So you can do like /program or whatever. and we're going to sort it, and then we're going to pass it to unique. And what that'll do is it'll say, here are the exact lines that we've reached. And so if we never reach here too, then we'll never see it in the output. So it's a useful little thing for unique and sort. Yep. All right. Okay. So we have grep and sed next. So these two I'm only going to quickly go over because they're really complex and they have a lot of idiosyncrasies with them. But they allow you to... most of the stuff we've been doing with the output is just taking the output and putting it somewhere else. But we haven't really done anything with it. So what grep lets us do is it lets us search through the output for specific words or specific phrases or specific things. Most things use it's a form of regex. So what we can do is like cat/user/share/dict/words. So that's our output, right? So what we're gonna do is we're gonna grep it for like foo. So all these things have the word foo in them. If you look in ZSH, it'll actually highlight it for you. Oh no, it won't. Never mind. Ignore that. So when you're grepping for things, you generally should be putting the thing first. You should do grep this for foo. This is generally what you want to do. Oop, other way around. You generally want to do this, but I'm trying to show the piping thing, so I'm doing the pipe, but you generally want to, if you're just catting and piping in, you want to just pass it in, because it's just more efficient and easier to look at and easier to do. So yes, we have this. So you cat it and you pipe it in. So what we can do is we can say, all right, I want to look for every foo, or I want to look for everything without an A or without an E in it. So every one of these words is missing the letter E. So -v says without. I don't know why V is without, but V means without. You can do -I, which is case insensitive. There's a bunch of different options you can do, and I don't really get into them. But you can say, I don't want to have a Z, or I'm grepping for Z. And if you notice, there's whoop. There you go. There's no Z's in the other capital. Anyways, yeah, so that's grep. Sed is, so grep is used to narrow down the results. So you have this large output, you don't need all of it, so we're going to narrow it down and say, I want the specific subset. Sed is used to modify the output, so it stands for stream editor. So let's say we're going to do this, we're going to just grep for words with the word sand in it. So all these words have the word sand. Now let's say we want to change the word sand into, I don't know, samp. Wow, look at me, I'm so funny. Substitute sand with samp. Oh, whoops. So every time we have the word sand in here, we're now replacing it with samp. So samp blast, samp board, samp box, sand boy. What the hell is sand boy? I don't know. So you can use sed to replace things like this. Sed also has a lot of options. It's actually Turing complete. It is insane. It is really cool if you like dorky things and you want to find really esoteric languages. You could do something like sed -v. Oops. What was it? -n. Yeah, so there you go. This will only print things, so you can actually replace the grep. So the grep before was saying we're going to look for everything with the word sand in it, and then we're going to do the replacement. But that's kind of redundant because you first look for sand and then you replace sand. So why not just look and replace at the same time? So you can do this, which says oops, I think it's -p. Let me just double check. No, it's -n. Yeah, so what this says is, -n says don't actually output anything, only wait for me to tell you when to output. So we're going to say this, and we're going to say if we substitute sand and samp, we're going to print it. That's what the P at the end is for. So without it, it doesn't do anything. With it, it prints. There's a lot of stuff you can do with this. There's you can translate things. You can say I want to only take the third line, and I'm going to substitute on the third line, stuff like that. So I'm going to just print the third line. I'm going to just print the last line. Stuff like that. There's a lot of funky things. The one thing I'm going to note is because sed does use some funky syntax like this $sign here, you generally want to single quote its arguments. Yeah. So that said, there's also awk. I don't think we're going to get too much into awk these days because of time and it's just really complex. But what awk does is it can be used to print out specific columns and stuff like that. So if I say echo, hello there world, what's up? What is up? This is used to print the first column. You can print the second column. You can print only if the input matches the word up. So if we don't have the word up in here, it won't print anything. There's a lot of stuff you can do. I actually wrote a night interpreter in awk if you want to go look at that. It's kind of fun. It feels kind of like JavaScript, but yeah. Oh yeah, I do. I've been known to use grep for that before. I don't think is grep minus r. Whoa, that's a lot of options. Yeah, or is it right there? All right, so that is that. I am going to let's see what else. Okay, so yeah, so you can use your favorite programming language on the command line too to do funky things like Perl or Ruby or awk or Python or JavaScript. I don't know why you do JavaScript for this, but you can use that to do specific things that you can't really do with command line scripting. One of my favorite examples is tallying. So what you do is you want to say, okay, I want to take the output and I want to see how many times something was said. So this is actually how I benchmarked some of my night code. Is I'd be like, how many times was the plus function run? So whenever the plus function is run, I'd print out the word plus or something. And so you can use Ruby to tally that. So you can say like, do output, like dot slash night slash run it slash whatever. You can do Ruby, and then you can do like begin x equals whatever, x current line plus equals 1. Then we do ends. We say print x dot sort, something like that. You can do stuff like this with your favorite languages. Most Python and Ruby are both and Perl are really good at this. I would highly recommend looking into them. I'm not a huge fan of Python, especially because you can't use the semicolon on the -e really easily. Perl was actually designed to be used like this. It was designed for this usage. awk was too, but Perl kind of took off. Yeah. There's also xargs. I don't know if I want to go into that too much. Xargs is used to execute things. So you can say like echo echo ipsum, and then we do xargs ls. And what that'll do is it'll say take ipsum and stick it as the argument to ls. There's a lot of stuff you can do here. There's like xargs minus I this, and then it says, so what that means is you're going to substitute with this. You can do this. So what this means is echo ipsum, write it out, and then we're going to pipe it into standard in, and xarg says, okay, for every line, you're going to take this piece of text and you're going to replace the line that we just got in with curly braces. So this is the exact same as if I wrote it's the same thing. There's more stuff you can do, like find, and you can do minus print 0. One of the problems with xargs is that if your file name or whatever you're passing in has a space in it or a special character, things can become funky. Or if it has a new line, that's also terrible, and that's actually where a lot of exploits come from, is naming files with new lines. Xargs will think it's two different files, even though it's one file. So you do like find, I should talk about find minus print 0, and you do xargs minus 0, and then stuff like that. So that's just there. If you know what that is, great. If you don't, it's not really all important. Just make sure to use the minus 0. I guess the last thing I'll talk about before I take a quick break is find. So find is a really helpful command. By default, it just looks through everything in your folder, just lists all the folders and all the files in there. It's so nice. So what you can do is like, I want to see everything in /code. So this is all the pieces of code in my Squire or in my code directory. Let's not do that. Code /Squire/source. So these are all the files that make up the Squire programming language. There's also, hey, look at this. We're gonna do a comma included. We're using the braces thing. So I'm looking for both include and source here, and that was this command right here. So you can use find to look through things, and you can really combine find with grep. So I want to find all the files that are value files. So I'm gonna do this. I'm gonna do grep value. See here, I just look through all the files in Squire, and I look for just the value files, the files that relate to values. Or let's say I just want to find the C files. Star.c. Oops. There, these are all the C files. Nope. Is it using egrep? There you go. We look for all of the .c files here. Everything that ends in C. Find also has some special parameters you can give it. You can also give it like this. You can say minus name star.c. Same thing. You want to be careful here, because if you do name star.c, this is just going to actually replace the star with... Whoa. Stop. This will replace the star with the expansion like we talked about before. So this will actually, if you look at this... Oh, no, that's one... Yeah, you're right. That's one thing to be wary about. In Bash, if star doesn't match anything... I'll get to that in a second. If star doesn't match anything, then it'll just be a literal star, and that's a huge problem. There's some options you can do. Shopped null glob. Shop null glob. Null glob is a way to set it so instead of it just replacing it with star, it'll do a it'll delete the entire star.c thing. Why we have to do the \\c? Well, because we do single.c. What it does is it looks for any... This is just regex, if you know regex at all. It says look for any letter and then a C following it. And since the entire folder has this include, there's any letter and then a C. So if we're going to be doing regex, we have to say escape the period. We don't want a period. Or we want a literal period and then a C instead of any character. You could also have done this. Does that make sense? Cool. Alright, I'm going to take a quick 3-minute break to eat most of my lunch and get some water, and I'll be right back. How the hell do I pause this thing? I guess I just hit that. Stop streaming.